Hello everyone. Today we're gonna learn section 6.3 describing the binomial distribution. So we have a learning objective here. Okay. So we learned the last time in 6.1 about the discrete of mean and standard deviation, right? So the formula is here. And the last section we learned binomial random variable, right? Okay, so the binomial experiment, we have to check the 4 criterion, right? So fixed number of trial and the success or failure. So success or and failure, sorry, success and failure. This is a come from bi, right? So binomial. And we have to have a P as a success of probability of success, and the trial must be independent, right? And then we have the formula, right? Okay, so today what we do, we have a mean and standard deviation of binomial random variable. So mu sub x n times p means that the sample size, number of trials, right? And the p probability, right? And sigma sub x, we have inside the square root to have n times p and 1 minus p, right? Okay, now the verified standard deviation formula. All right, so let me just take a look. Use the probability distribution from example 1. So I did not go over example 1, but here is. And to find the standard deviation from 6.1, we are using same formula from 6.1, discrete random variable standard deviation. And then the textbook shows that the standard deviation for binomial. Yeah. So I'm going to show you. So this is a 6.1 discrete random variable text, what is called the formula, right? This is the one. Okay. Then we went over this one, right? Yeah. So we make a column x squared times p times of x, which is the probability, right? Okay. Then mu was 2.3044. So we do a lot of work, this column, and then we are using the formula from discrete random variable standard deviation, right? And then we substitute, we get 1.19. Yeah. Okay. Now, if we are using binomial standard deviation formula, n times p times 1 minus p, this says that n equal to 6, probability is 0.384. So n times p, which is 6 times 0.384 times 1 minus 0.384. So let me see. 0.384. What this one come from? Yeah, this is from the beginning, the given, but we did not have that, right? So they say that from the example 1, we had that 38.4% of US household own a dog. Of US household own a dog. That's how we're using 0.348. That probability, okay? All right, so we substitute everything for those numbers. So we get the 1.19. So even though we are using binomial probability standard deviation, we get the same answer. So we don't have to do this work, right? This is for discrete random variable. The formula, the standard deviation, right? Okay, so the results are same, but look, this formula for only the binomial. So we have to check that whether example satisfied four criteria, right? We said earlier in the last semester, no, not last semester, last section, right? Okay, otherwise we cannot use this one. This is more simpler, right? Yeah, we're gonna do the more, the standard deviation for binomial random variable. Make sense? All right. Let us do this one. So we have example 3, finding the mean and standard deviation. Stephen Curry of Golden State Warriors make 91% of his free throw attempts in basketball games. Assume he takes 20 free throw attempts. Further, assume that his attempts are independent of each other. Okay, let X the number of free throws he makes out of 20 attempts. Okay, we check that whether this is a binomial experiment or not. Okay. All right, so I brought this one here. So let's check that. The check number 1, n equal to fixed number of trial. What do you think? N equal to 20? Yeah. So fixed number of trial. Okay, number 2, success and failure, right? Which one is success? So he throw attempts 20 times, right? Make a shot, then that's the success. Miss, that's a failure, right? So make a the shot, success, miss, that's a failure. Okay, what is the probability in that case? 0.91, good job. Number 4, they said independent, right? So 4, yeah, first shot, make one first one, second one miss, or first one missed, second one make a shot, independent, right? Yeah. Independent. All right. So second one, we want to find the mean and standard deviation. All right, so I brought the formula too. So let's find out mean. So mu sub x equal to n times p, which is n in that case is 20. And the probability is 0.91. What do we have? 18.2. Yeah. So that means you should expect him to make 18.2 free throws for each 20. Wow, that's a lot, right? On average. Okay, so I wrote down the interpretation and standard deviation, right? So let's say using standard deviation. So standard deviation, oops. we have a sigma sub x square root of n times p times 1 minus p. So square root n times p, we had 18.2. Or we can say that 20 times 0.91, that's fine too. 1 minus p, which is 0.91, right? Can you please calculate? Okay, so we have 1.28. All right, what this means? This means the standard deviation. So from the standard deviation is average distance from average distance from each data set from the mean, right? So in that case, how do we interpret? We can interpret the Stephen Curry will make 18.2 free throws on the average for every 20 attempts, right? And he makes with a standard deviation of 1.28 in that case. That means he generally make 1.28. So we can say that 17, about the 18, or about the 19, 1.28. Yeah, it's less than 1.5, right? So we can say that 1, so 17 or 18 or between 19 because of 1.28. Is it clear? Yeah, let me write down. So here, I wrote down here, right? So 18.2, we can say the 18, so subtract 1.28, so it's about the 17, add 1.28, about the 19, all right? All right, so let's talk about the shape of the binomial distribution. So talk about the Stephen Curry free throws, 20 attempts, yeah? Okay, now, what if we have the n equal to 10 and probability is 0.9, right? Then we have bell shape. We can see that bell shape. How about n equal to 10? The probability is more smaller, 0.15. Then we have a skewed rate. What is probability is the same as the Stephen Curry had earlier, 0.9, 0.91, right? So n equal to 10, probability is 0.9. That's the skewed left. All right, let's take a look. What if we have, look, this one is n equal to 10, probability is 0.9. This one has n equal to 50, probability is 0.9. Then we can see that the probability closer to the bell shape, right? So this one, right? How about the shape? How about the n equal to 100? And then same probability 0.9. Yeah, more bell shape. What if 425? It is bell shape, right? Yeah. Because this one a little bit skewed to the left, going to. Yeah. How about, okay, graphically, we can see that we have the same probability. Then when is n is increased, right? The shape toward to going to bell shape, right? Okay. How do you check? Algebraically, so we can check that n times p times 1 minus p greater than or equal to 10. We can say that the shape is bell shape. All right. Okay. So let's take a look. This one shows that algebraically whether n times p times 1 minus p greater than or equal to 10. So n equal to 10, we substitute n times p and then same p, right? Then less than 10, that is the first shape. Second one, n equal to 50, we substitute. Yeah, it's not greater than 10 or equal to 10. N equal to 100, still 9, less than 10. Now, n equal to 125, so it's larger than 10, so we confirm the shape is the bell shape. The probability histogram is bell shape. Yeah? Okay, so bell shape. All right, so we have a summary, center, which is mean, right? In binomial, mu sub x equal to n times p, variation, standard deviation, sigma sub x equal to square root. Inside the square root, we have n times p times 1 minus p, and shape will be bell shape if n times p times 1 minus p greater than or equal to 10, right? Okay, let us do this question. Oh, a student forgot to study 400 question multiple choice test. Each question has 4 possible answers, A, B, C, D. The student has decided to randomly guess the answer to each question. Let X the number of answers that they guess correctly. We check whether this is a binomial so that we can use that, right? Otherwise, we cannot use, right? All right. And then we're gonna check the shape later. And center variation, of course. All right. Okay. So the first one, fixed number trial, is it? 100? Okay, good. 100. Fixed number trial. Number 2, success, right? Success, or wrong, failure, right? Okay, what's the probability? So 4 possible answer, how many one get right? 1 correct, right? So right. So number of right over number of sample space, sample size, 1 out of 4, which is a 0.25, right? Okay, number 4, independent. So the first outcome does not affect the second outcome does not affect to the third outcome, vice versa. Yes, independent. So we say that X is binomial random variable. Okay. Since we prove they are binomial random variable, we can use their formula, right? So mu sub x, which is n times p. So n in the case 100 times p, which is 0.25. Now, can you please calculate? 25, yes, absolutely. Sigma sub x, so square root of n times p times 1 minus p. So n times p, we have 25, and 1 minus p, 0.25. Can you calculate? 4.3? All right. Now, check the bell shape. So n times p, n times n times p times 1 minus p. So whatever is inside, right? Inside the square root, we check the whether inside the square root is greater or equal to 10, right? So that is 25 times 1 minus 0.25. This one also. So what do you have? It's 18.75. It's greater than or equal to 10. So we can say that bell shape, right? All right. It's good? Okay, so let's talk about the unusual result. All right, so this is come from empirical rule, right? So we have that in chapter 3. Look, we have 95% within 2 standard deviation here. All right, and then look, z-score is distance in terms of standard deviation, right? So z-score is goes the same number with the standard deviation. Means that mu equal to 0 here, and then z equal to 0 here, and then this one we said that 1 standard deviation, right? From the mean, right? So this will be z equal to 1, z equal to 2, -1, sorry, let me write down. So in that case, z equal to 0, mu equal to 0, right? So 1 standard deviation, so z equal to 1. In that case, z equal to -1. And here z equal to 2, z equal to, z equal to -2, right? So we learned from that when talk about the z-score, below, z-score is below -2, above +2. That's an unusual event, right? Remember? No, remember? Okay, that's fine. From now on, remember, yeah? So unusual part. So unusual, 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 yeah? And then looking at the empirical rule say that that's 95% within 2 standard deviation, right? So we can say that 5% will be unusual result. Yeah, unusual. And then we can make a mu minus 2 times of sigma left side. And then there is a mu plus 2 times of sigma, right? So this is a 2 plus. Make sense to you? All right. Okay, so let us do these questions. 100 questions, multiple choice, the earlier question, right? And this question is about for students who are guessing what are the typical scores you would expect to see. Is it likely that someone who scored 58 was guessing? Okay, so we need to find the value that 2 standard deviation, within 2 standard deviation. That's the typical score. And more than 2 standard deviation will be below negative part 2 standard deviation, above 2 standard deviation, right? So that will be the unusual part, right? Okay, so check that. Check it out. So let's see. So we have mu minus 2 times of sigma. Okay, so, oops, I don't know the value. Let me bring the value. Mu and sigma, right? Okay, so I got this information from the previous question. So let's check that. Mu sub x minus 2 times of sigma sub x. Yeah? All right, so mu, which is 25, minus 2 times of sigma sub x, which is 4.3. Can you check? Can you calculate? It's 16.4. How about addition? Addition. So 25 plus 2 times of 4.3. Okay, so three, three, no, 3, no, 33 point, right? 33.6, yeah? Okay, so this is a typical score, right? So typical score between 16.4 and 33.6 scores, right? Okay, 58 was unusual. Okay, yes, unusual, right? Because 58 is above from the 2 standard deviation, right? Likely that, no, unlikely, yeah. 58 is unlikely score. Since it's above 33.6, yeah? Okay, let me show you the nice picture here. Okay, so here's nice picture. So this is the mean, 25. And then we found from earlier, right? So mu sub x bar minus 2 times of sigma sub x gives the 16.4. And here is mu sub x bar, not x bar, sorry, mu sub x plus 2 times of sigma x, yeah? So 33.6. And then after that is the unusual part, right? So we have this part is unusual. This part is also unusual, right? And then 58 is here. Wow, 58 is 2. 58, right? So 58. I could not say 58. So where is the 58? So probably here is the 58. Yeah, usually high score. Yeah. Make sense? Okay, so we are done for this section. Thank you for watching. See you next time.